So for the given circuit we have to find current I1 and current I2, and if we do that we will be able to find the corresponding voltage drop here, V1, V2, and if needed we can find the corresponding powers as well. So that's fine. We will just focus on finding the target for finding the current first. So what we will do, we will use equivalent resistance methods. That means we will try to minimize the given resistances. That here there are two parallel resistances and here there are two parallel resistances. So we can see that this is the 30 volts, and if these two, the equivalent of these two will be just one resistance, and value will be, since these two are in parallel, that will be 12 times 6 over 12 plus 6, that is 4 ohms. Similarly these two, 40 and 10, so the equivalent will be 40 times 10 divided by 40 plus 10, so that's 50. So the equivalent will be 8 ohms. So this way we can find the total current. First we can find the total current that is coming out of the voltage source. So that will be 30 divided by 12, so that's 2.5 amps. That will be the current, if we can call it I. Now once the I comes, now we will redraw the original circuit, which is this one and this one. So that's 12 ohms here, that's 6 ohms there, and we have 10 ohms there and 40 ohms there. So the current here, the total current I, maybe I use a different color, this one is 2.5 amps. Now when this current arrives here, it has two parallel paths to go, and what happens is a rule that is known as current divider rule, that gives us what is the current in any of these two branches, in each of these two branches. So that one comes like this. So if we say that we want to find this current, which is I1, I1 will be the total current divided by sum of the two parallel resistances times the other resistance. That's how we can find I1. This happens because this gives the total voltage drop. Basically the voltage drop here and voltage drop here, these are equal. So we won't go into the derivation of the rule, but that's how we find, we use current divider rule when we have two parallel branches to find the current in any of those two branches. So this one gives us I is 2.5, so I1 will be 2.5 over 18 times 6, so that will be, I1 will be 0.833 amps, or we can say 833 milliamps. So that's the current here. I will use a darker color, and so this is the current here, which is 833 milliamps. But we also want to find the current through this branch. So again, when the current that comes here is, again, if we think that what is the current here, because these two current gets added and then again they are splitted through these two branches. So again we apply current divider rule with the total current being 2.5 amps for these two parallel branches, 40 ohms and 10 ohms. So when that happens, we have, again, we want to find I2, which is the current through the 40 ohms branch. So that will be total current, which is 2.5 divided by sum of the two parallel resistances times the other resistance, because we want to find the current through this resistance, so we will multiply by this resistance, and that gives us 2.5 here over 5, so that gives us 0.5 amps, which is 500 milliamps. So these two are the currents. Now if we want to find the corresponding voltages, V1 will be just I1 R, I1 R. What is the R? That R is 12, so that will be 0.833 times 12, that is 10 volts. And similarly V2 will be I2 times R, that is I2 is sorry, that's 0.5. We have to remember that the unit has to be amps, not milliamps, so we have to convert it into ampere. So that's 0.5 times current, the voltage, sorry, the resistance is 40, so R is 40, so that gives us 20 volts. Similarly, if we want to find P2, that will be I2 square times R, and that is 0.5 square times 40, that gives us 0.25 times 40, which is 10 watt. So that's how we can find the power. Similarly, for P1 it will be again I1 square R, and I1 square is 0.833 square times R is 12, that gives us 8.33 watts. So that's the power P1. So this is how we can, once we find the each of the currents, we can find the corresponding voltage drops and power dissipated through that by that resistance. So this is a very simple problem, but we have applied the current divider rule for solving this problem.